Assalamualaikum and a very good day to everyone. We will be presenting our final year project entitled Bound for the Second Hankel Determinant of Certain Generalized Class of Close-to-Convex Function. Our group are supervised by Encik Abdullah bin Yahya.
Assalamualaikum warahmatullahi wabarakatuh. I'm Nurul Yasmin binti Mazlan as presenter 1.
I'm Nur Shamimi binti Muhammad Azmi as presenter 2.
I'm Nushair binti Rosman as presenter 3.
For our presentation outline, we will cover 11 parts. Let's start with the first part.
For the abstract, geometric function theory is a study about the geometric properties of certain classes of analytic function. There are many classes of function in geometric theory that has been introduced in this field. And every function have their own properties such as radius properties, extremal properties, coefficient bound, and etc. The problem is there are a few researchers that are interested in discovering these properties of function because the process of finding the new theorem involves many definitions that need to be applied. In this research, class of close-to-convex function W alpha delta beta is introduced which satisfies this condition. Lemma of Pomerang, lemma of Topliss determinant, lemma of Libera and Zokliewicz are used to obtain our main result. This study may be giving the benefit for the research in the future.
Geometric function theory is the branch of complex analysis that studies geometric properties of analytic function established around the turn of 20th century. In 1907, Cube introduced the theory of universal function, which is a classical problem of complex analysis. Next, in 1916, Lieberbach, a German mathematician, had introduced the geometric function theory and proved the second coefficient of C2 of a function f element in N in the form of Taylor series. The Taylor series can be seen on the left. Second Hankel determinant plays an important role in the theory of universal function. It also one of the coefficient inequalities that can be used to solve the solution of new subclass of analytic function.
Now, I will explain about the problem statement. This research is focused on geometric function theory. There are many classes of functions in geometric function theory that have been introduced in this field of research, where for each one of the functions has their own characteristics such as radius properties, extremal properties, representation theorem, distortion theorem, coefficient bound, arc length and area, and also center and radius. However, the problem is there are only a few of researchers are interested in discovering these properties of function, and it involves many definitions that need to be applied in the process on finding a new theorem. As a consequence, this challenge has received and action will be taken to define a new subclasses of analytic function and concentrate on finding coefficient inequality, namely second Hankel determinant.
We have three objectives for this research. 1. To define a certain generalized class of close-to-convex function. 2. To determine the representation theorem of certain generalized class of close-to-convex function. 3. To find the coefficient inequality of second Hankel determinant by using lemma proved by Pomerang, Topliss determinant, Libera, and Zokliewicz.
Next, for the significance of the study, the generalizing new subclass of analytic function will be discussed in this research. A new result of second Hankel determinant will be determined, and this study may be useful for the other researchers to exhaustive their research in the field of mathematics.
I proceed with the scope and limitation. For the scope, geometric function theory has a wide field to explore. Thus, in this research, our researchers are concentrated on the class of universal function. In addition, this research is focusing on one of the coefficient inequalities, where the researchers will focus on upper bounds. Furthermore, there are three limitations in this research. First, this research is limited on upper bound of universal functions. Second, there is a lack of prior research studies on this topic due to no researchers that interest in this field. And lastly, different definition, theorem, and a long equation are also one of the challenges for us in the study.
For the literature review, the table shows the year, author, and description. Many authors found the solution of three subclasses: convex function, class of starlight, class of close-to-convex. Chanting et al. 2007 found the upper bound for the function belong to the class of starlight and convex function. Shaw and Muhammad obtained for the class of starlight in 2008. Mabalala in 2009 proved for the class of starlight function. Kaharudin et al. In 2011 derived the sharp upper bound of the class of close-to-convex function, while Krishna in 2012 obtained the upper bound for the function f belong to the p-valent starlight function and convex function. Thus, all the past researchers are using the same method, which is lemma that has been proved by Pomerantz, Topliss Determinant, Liberal, and Zolkiewicz. Chanting in 2006 was the first researcher who applied second Hankel Determinant in solving the upper bound of subclass first analytic function. All the process in second Hankel Determinant is similar to the Chanting, Shaw, and Babalola. Thus, all the past study has increased our motivation to make their research as our reference.
Next, methodology. There are 6 steps involved in finding upper bound for second Hankel determinant. The steps are shown as follows. Step 1. Using the lemma. There are 3 lemma are used, such as lemma of Pomerantz, lemma of Topliss Determinant, and lemma of Liberal and Zolkiewicz. Next, step 2 is about to determine the value of A2, A3, and A4. It needs to compare the solution with the previous lemma to get the value. Step 3. Solve for second Hankel determinant. The multiplication of second Hankel will be calculated. From there on, it will attain the result of A2, A4 minus A3 the power of 2. Next, in step 4 and 5, it will find the value of Fp eta, Gp, Fp epsilon, Jp with the respective derivative. Next, in step 6, the result of upper bound for the new class of convex function can be achieved using the similar method that used by Kaharudin. We obtain A alpha data from the result of upper bound by using quadratic formula.
I proceed with our result. The result for upper bound for second Hankel of second Hankel determinant can be verified and reduced into corollary and a few remarks. For corollary 4.4.1, when beta equals to 1, we get A less than equals to 1.206. This inequality obtained is coincide to the result of the authors, which is Kaharudin and others in 2011, but our result is bigger than them. For remarks 4.4.2, beta equals to -1, we get A is 0.3797, while remarks 4.4.3, the beta that we use is 0, we get 0.7119. Next, beta equals to -1/2, we get 0.9269, like stated in remarks 4.4.4. Lastly, for remarks 4.4.5, we get A less than equals to 1.0265 when beta is 1/2. Thus, the upper bound for second Hankel determinant can be reduced to several types of new classes of functions.
The main focus of the research is to find the extremal properties and coefficient inequalities of class-to-convex function. The 3 objectives have been achieved in this study. The new result for second Hankel determinant of class W, alpha, delta, beta, is shown in the previous slide, which is our result is similar to Kaharudin. We got the upper bound less than 1.2. In the future research, there are more results can be achieved from the class W, alpha, delta, beta, such as radius properties and also the third Hankel determinant.
That's all from us. Thank you.